after this class, it will show up pretty much in every math class you ever take from here on out. So we're going to talk about sine, cosine, and tangent. So we get to learn about several new buttons on your calculator too. All right, so and this is a good part of what was on the park test, from what I could tell. So the day after the park ends, you'll know what sine, cosine, and tangent mean.
That's great.
Right. So let's talk about why these things work first, and then we will get into a little more detail. I want to make this one bigger. All right. So here we have two right triangles, and we know that these angles are congruent. And I'm going to call this A and C, small c, and this capital A and capital C. Since these two pairs of angles are congruent, what do we know about those two triangles? They're similar. So we could say the triangles are similar by angle. So that means no matter how big or how small these triangles are, they're going to be similar. And what did we say about the corresponding sides of similar triangles? They are not congruent, but similar. What was our big technique in the similarity chapter? Write a ratio of proportion. So the corresponding sides are going to be proportional. So we could say A over C equals big A over big C. So no matter how big, no matter how small those triangles are, if they share a right angle and one other angle, those ratios are going to be the same. When we're talking about trigonometry, all we're talking about is these ratios. So because the triangles are going to be similar, they're going to have that same ratio. We give those ratios a special name. That's all trigonometry is giving those ratios a special name. That's what sine, cosine, and tangent are. So let's talk about those. We'll call them trig ratios for short. What they all have to do with those triangles being similar by angle. So for what we're going to do today, we're going to label our triangle in a specific way. There's our 90-degree angle. In trigonometry, we like to call our angle theta. That's what the Greek letter of theta. I don't know why they like Greek letters in trigonometry, but you'll see that for angles a lot. So that's theta. And I will also call this, we could call it angle A. And we're going to label the sides. This side that's next to the angle is the adjacent side. This side that's across from the angle is the opposite side. And the hypotenuse is always the hypotenuse. So all we're going to do with trigonometry is make ratios of the sides of this triangle and give them special names. So we say the sine of angle A, or the way you usually see it written is sine theta equals the opposite over the hypotenuse. So we just give a special name to that ratio. And as long as this angle theta, is whatever that angle is, as long as the right triangle has that angle, that opposite over the hypotenuse ratio is always going to be the same. The other ratio is the cosine of angle A, or the way you'll usually see it written is cosine theta equals the adjacent over the hypotenuse. So that's the special name we give for that ratio of the sides of this right triangle. And then our third one, tangent of angle A, or tangent theta, is the opposite over the adjacent. And that's all we're doing with trigonometry. And with that idea, we can do a lot of things. Now we have a nice little acronym to help us remember these ratios. You may have heard it. SOHCAHTOA. SOHCAHTOA, what it means is the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And tangent is opposite over adjacent. So SOHCAHTOA is going to help us remember these ratios. And these ratios are what we're going to use to solve problems using trigonometry. And what we're talking about today is trigonometry that has to do with right triangles. So we need a right angle there to do the trigonometry that we're doing today. If it's not a right angle, you have to do some more work, and you'll learn about that later. So it's important to remember that the sine, the cosine, and the tangent are just ratios of sides of this triangle, and we're going to use those ratios to solve different kinds of problems. So what I want to do, this is our idea. This is our big idea for today. I just want to use that idea to set up and solve some different problems. So we good so far? All right. So the first kind of problem would give you a triangle. One kind that you'll do with this first type of trigonometry that we do today. Is you might get a question that says, write the trig ratios for angle A. And in your book it'll say the trigonometric ratios. I'm just using trig for shorthand. So all it's asking us to do is make those ratios with this triangle. So the first thing that I suggest that we always do with trigonometry problems is label the triangle. By label the triangle, I mean we're going to, just like we did with the other types of problems we did with the A, the B, the C, the short, the long, the hypotenuse. Here we're going to label opposite, adjacent, and hypotenuse. So we're looking at angle A. Angle A is the angle that we're interested in. Angle is the four side. Is that the opposite, the adjacent, or the hypotenuse? Adjacent. It's next to. The 3? Opposite, across from, and the hypotenuse is always the hypotenuse. All right, so now the problem's just asking us to write the ratios. So the sine of angle A is the opposite over the hypotenuse. And I can write this out just so we see it. 3/5. Cosine of angle A is the adjacent over the hypotenuse. 4/5. Tangent of angle A is opposite over adjacent. equals 3/4. And that's all we'd have to do for this problem.
That's it.
For this type of problem. Write the trig ratios, that's all it's asking us to do, is write those ratios down. Now let me ask you a little twist on this question. What would we do if we had this right triangle and they hadn't given us one side? Then we could do the Pythagorean Theorem to find the missing side. So if they only give us two sides, we can use the Pythagorean Theorem. The Pythagorean Theorem always works on a right triangle. So if we have two sides, we can use the Pythagorean Theorem to figure out the third side. So this is kind of the most basic problem that we would do with trigonometry. It's just writing the ratios. But what we want to do, we don't want to just do this. We want to use trigonometry to solve problems. So what we can use trigonometry for is we can find missing sides of right triangles if we know a side and an angle, or we can find missing angles of right triangles if we know two sides. So I'm going to give us a set of steps that we can use for all of these different kinds of problems. So our first step is label the triangle. And by that I mean we're going to write down our opposite, our adjacent, and our hypotenuse. We're going to label our sides. Opposite, adjacent, and hypotenuse. Then we're going to decide which trig ratio to use. And the way we decide is based on which sides of the triangle we have, we use SOHCAHTOA. Depending on which sides of the triangle we have, we'll use the appropriate ratio. Then we're going to write an equation. And our equation, depending on which ratio that we use, will always look like one of these three. The sine of the angle equals the opposite over hypotenuse, if that's the trig ratio we're using. The cosine of the angle equals the adjacent over the hypotenuse, if we're using cosine. Or the tangent of the angle equals the opposite over the adjacent, if that's the trig ratio we're using. Then we're going to solve for what we need. So we want to get x by itself, if that's what we're looking for. And then finally, we're going to use your calculator. And this, if we set up our problem this way, label our triangles, write our equation, we can set up any kind of, basically any kind of problem that we're going to use trigonometry for in this class. So what I want to do is just go through and set up and solve several kinds of problems using trigonometry. Okay, questions so far? All right, so let's do a few of these. And while we do this, I'll show you, you might want to, if you have your calculator with you, you might want to pull your calculator out so you get a little practice entering these into your calculator, because I'm going to demonstrate how to use your calculator with these. All right, so this problem says find x. The hint that we're going to end up using trigonometry here is that we have an angle. It's not, this isn't going to, or we have a right triangle. We have to have a right triangle. We have some angle that's not a special angle. It's not a 30, a 60, a 45. And we only have one side of our triangle, so we can't use a Pythagorean theorem. So let's label our triangle. X, opposite, adjacent, or hypotenuse for this angle. Opposite. So it's across a triangle, it's opposite. 12, the adjacent or the hypotenuse? Hypotenuse. The hypotenuse always along the side, always across from the 90 degree angle. So we've labeled our triangle. What trig ratio tells us what trig ratio do we use with the opposite and the hypotenuse? Looking at SOHCAHTOA. Sine. So we're going to use sine because we have the opposite and the hypotenuse. We look at SOHCAHTOA, it says the sine of the angle is the opposite over the hypotenuse. So we're going to use sine. So we write our equation. Sine of 32 degrees equals the opposite over the hypotenuse, x over 12. And what do we do to get x by itself here? Multiply by 12. Those cancel. So I get x equals 12 times the sine of 32 degrees. I'm going to go to my calculator. And I'm going to enter it just like I wrote it down. On your calculator, before we do this, you need to make sure it is in degree mode. So if you have a Texas Instruments calculator, you press the mode button, and this cursor should be flashing over to degree. If it's not over that, you just need to move it so it's over degree and hit enter. And then we can quit out of there. So we should be in degree mode. And I'm going to enter this exactly like I wrote it down. 12 sine 32. 12 times the sine of 32. And I'm going to close my parentheses. Hit enter. And it tells me that side is about 6.36 units long. If you need help getting your calculator working, whatever, during work time or tutor time, something I can show you if you're having trouble getting your calculator to work the way you need it to. So there's what we do. And all of our problems are going to be some variation on that set of steps. So let's look at another one. So here is our setup for this one. 90 degree angle. And this says find x. We're missing a side. We can't use a Pythagorean theorem because we don't know the other side. We have this angle, so that gives us a hint that we're using trigonometry. So we label our triangle. 7, opposite, adjacent, or hypotenuse for this 47 degree angle. Adjacent. X, opposite or hypotenuse? Opposite. So then we look at SOHCAHTOA and say, which trig ratio are we using with opposite and adjacent? Tangent. So then we write our equation. So we say the tangent of the angle that we're looking at, 47 degrees, equals the opposite over the adjacent. Almost the same problem now. We're just going to use a different button on our calculator. So how do we get the x by itself? Multiply by 7. Those cancel, so I get x equals 7 times the tangent of 47 degrees. Go to my calculator, plug that in just like that. 7 tangent 47, and it tells me 7.5, about 7.51 is how long that side would be. Do you know who does trigonometry on the beach in England? Tangents. Tangents. All right, questions on that one? That would give you an F plus. All right, let's look at another one. All these problems are essentially the same, just how you set them up. So this one, a little different setup that we need to be careful with. So here's my setup. This is x, and this is 8. And we want to find x. So we're going to label our triangle x, opposite, adjacent, or hypotenuse. Hypotenuse. And 8, opposite or adjacent. Adjacent. So then we look at SOHCAHTOA, we think about SOHCAHTOA, and we say what trig ratio are we going to use here? Cosine. Cosine tells us about the adjacent and hypotenuse. So we use cosine. We write our equation. Cosine 52 degrees equals the adjacent over the hypotenuse. So this one's a little different than the last one. How do we get that x out of the denominator? Multiply by x. We've done problems like this before, but I just want to make sure so those cancel. So I get x cosine 52 degrees equals 8. How do we get x by itself now? What is cosine 52 doing to x? Adding, subtracting, multiplying, or dividing? Multiplying. How do we undo multiplication? Divide. So I'm going to divide by the cosine of 52 degrees. That's just a number. Those cancel, and I get x equals 8 divided by the cosine of 52 degrees. And I'm going to go to my calculator and enter it just like this. 8 divided by cosine 52, close the parentheses, and I get 12.99. And we're done. Same set of same set of steps, same process for every single problem. So questions on those examples? All right, so on all of these examples we found missing sides. We can also find missing angles. It's the exact same process. There's nothing different. We just use a different button on our calculator. We use the same steps as before. But at the end, we're going to use the inverse sine, cosine, or tangent button on our calculator. The inverse sine, cosine, tangent gives us an angle. So those buttons on your calculator, most calculators now, will look like this. Inverse sine, inverse cosine, and inverse tangent. The inverse gives us an angle. But we set the problem up the exact same way. We write our equation the exact same way, except this time instead of a side being x, or whatever we're trying to find, an angle is going to be x. And then to get our angle, we're going to use an inverse trig function. So let's look at an example of using an inverse. Everything's exactly the same, we just use a different button on our calculator. So we're still finding x, but this time x is an angle. We're going to do the exact same thing. Label our triangle. Is 7, x is the angle we're interested in. 7, the opposite, the adjacent, or the hypotenuse? Opposite, 15. Hypotenuse. Then we think about SOHCAHTOA and we say what trig ratio tells us about opposite and hypotenuse? Cosine. So we're going to use cosine. So we write our equation. Cosine of the angle equals the opposite over hypotenuse. Did we mess up? It should be sine. Use sine. I was seeing if you guys were paying attention. Good catch. All right, now since we're looking for an angle, we say that x equals the inverse sine of 7 over 15. The inverse sine gives us an angle. So I'm going to go to my calculator and enter it exactly like this. So I'm going to do the inverse sine, which is this one, this shifted button here. Inverse sine of 7 divided by 15. Make sure you close the parentheses there, otherwise your calculator is going to do not what you want it to do. Hit enter, and that says that angle is about 27.82. What if this problem asks us then to find the third angle in this triangle? So we know that's 27.82. How could we find the third angle? They all have to add up to 180. So don't forget all the other things that we already know how to do. All right, questions there?
So we just use the inverse
when we want to find an angle. You set up the equation the exact same way, but when we're looking for an angle, we use the inverse.
Yes.
All right. Homework.